Alright. Day 14. I finally got day 13 done by using a system of linear equations. Here we go. Ciao. Oh yes, implements day. Okay. Test that. Get my boilerplate ready. Do. And we're gonna have like some sample input, and it's gonna be this. What the heck? Okay, and we're gonna have let's see. I don't know exactly what we're doing yet, how big the numbers are gonna be or anything. One of the historians needs to use the bathroom. Fortunately, I'm gonna get a drink. Do it. One of the historians had to go to the bathroom. You know there's a bathroom near an unvisited location on their list, so you're all quickly teleported directly to the lobby. The area outside the bathroom is swarming with robots. To get the historians safely to the bathroom, you'll need a way to predict where the robots will be in the future. Great. Fortunately, they all seem to be moving on the tile floor in predictable straight lines. You make a list, your puzzle input, of all the robots' current positions and velocities. One robot per line. Okay, so here's a position, and here's its velocity. Sweet. Each robot's position is given like that. Yeah. Each robot's velocity is like that. Tiles per second. Yeah, tiles per second. Positive X means the robot's moving to the right. Yeah. Positive Y means the robot's moving down. Sweet. Thank you. So velocity, yeah. Robots outside the actual bathroom are in a space which is 101 tiles. Huh? Oh, 101 tiles wide, 103 tiles tall when viewed from above. However, in this example, the robots are in a space which are only 11 and 7. The robots are good at navigating over under each other due to a combination of springs, extendable leg, blah, blah, blah. So they can share the same tile and don't interact with each other. Sweet. Visually, the number of robots on each tile in this example looks like this. Like at their starting positions or what? Yeah. Oh, it's just me. There's 2 robots here. At 0, 0, 1, 2, 3, 0, 3. Wait, what? 3, 0? 3, 0. Is it backwards? Extra number of tiles from the left. Oh, okay. So it's actually flipped. So it's actually like column row. I'll just think of it like that. Column row. Yeah. These robots have a unique feature for maximum bathroom security. They can teleport. When a robot would run into an edge of the space they're in, they instead... Okay, so it's like Pac-Man wraparound. Alright, sweet. Cool, man. The historian can't wait much longer. So you don't have to so you don't have to simulate the robots for very long. Where will the robots be after 100 seconds? All right, this is fun. I'm gonna simulate it, and I know it's gonna bite me in the butt for part 2, but obviously, the obvious choice right now is to simulate the robots moving around. To determine the safest area, count the number of robots in each quadrant after those 100 seconds. Robots that are exactly in the middle, horizontally or vertically, don't count as being in any quadrant. So the only relevant robots are... So robots that are exactly in the middle. Okay. Figure that when I get there. Let's just simulate the robots first. So predict the motion of robots. In this example, the quadrants contain, multiplying them together gives a safety factor of 12. So that sample input expected is 12. And I'm gonna have a day 14. Oh, whoops. Actual equals day 14 dot part 1 sample okie dokie. Wait, what are you mad at? Why are you mad? Oh, because it's not implemented yet. I don't know why I'm trying to like go super fast, because I'm just not fast. I mean, I'm doing like tests and stuff, so like I'm doing Advent of Code really corporate style. So we're gonna have the data. And just gonna print out the results of part 1. I'll just call it part 1, please. Okay. What's the best way to simulate these robots? Let's do like a integer grid, I guess. Yeah, I can just do that. I'll have like an integer grid, and the initial positions I'll just I'll increment by 1, and then when a robot moves, I decrement the current position, increment the next position, and use modulo for wraparound. Simple. Here's the grid. Let's do rows and columns. And let's init grid. What do I need to know for this? I'll take the data. Let's parse that data now. So first, let's wait. So with this example, let's see. Init grid. So init grid. So I'm actually going to be setting. It's fine. So rows, columns. So what was the sample again? 11. Okay, 7 rows, 11 columns. 711. And I can honestly just put those up there. I don't know what I'm doing. Since, I mean, seems like they're like hard-coded. So 7 rows and 11 columns. Yeah. And we're gonna say grid equals new int m and n, and we're gonna do arrays.stream data.trim.split by new lines, and for each one of those lines, what the heck? For each one of those lines, we're going to parse it. So the position is going to be line.substring line.index of equal sign +1 to line.index of space dot split by the comma. Oh. Gosh. Let's do this. Ugly. Ugly. Dot. Can I make this a little better? Like maybe by doing that? Yeah, that'll look better. So that's the robot position. What's the other thing I need to know? The velocity. It's going to be almost the same. Come on, man. The velocity is almost going to look the same. But it's going to be line dot index last index of. Is there spaces at the end? Are those spaces? I can't tell. Oh, not there. Let's get that and put it in a file. No, no spaces. Last index of. You don't need this one now. Oh, you do need that. You just don't need this part. So that's the velocity, and then you just want to say grid. Oh, maybe I should how should I do this actually? How should I do this? I could represent the grid where each cell is a list of like robot objects. A matrix of lists. That's kind of weird. It's kind of chonky. Where each cell is a list of robots. Could be empty list. There's no robot there. Might do that. And then iterate through the grid. And then, okay, for each cell, for each robot in that cell, move the robot. Oh, but you gotta make sure you don't move the robots twice. So you want to do like a new grid kind of thing. So it would be a list of lists of lists. Ugh. Oh, it doesn't have to be a list. It could be an array. 3-dimensional array of robots. Okay, let's do that. So I'm gonna have a robot. Let's think about this before I do this. Is this gonna be okay? Yeah, this should be fine. So robot's gonna have an I and a J, and that's. Oh, it's gonna have a velocity too. Robot And it's going to take in the I, the J, the delta I, and the delta J. And okay. And this is now going to be an array of robots. So it's going to be a grid of arrays containing robots. Okay. Oh, shoot. Well, how many robots are there? Crap. I guess I have to use a list. All right, make it a freaking list. It's gonna be nasty. Ugh. What? Come on, dude. So a grid of lists of robots. Grid equals so it's going to be this many rows. I don't know. Let's just do it with for loops. What the heck am I doing? New array list. Grid.add new array list. Ugh. So, shoot. Give me a list of rows. So yeah, I'll just have like a list of a robot. Row equals new array list. Yucky. And then go through each column. Row dot. Yeah, and then for each column, we're just gonna add a new list. So we'll say like row dot add new array list, and then grid dot add row. It's gonna be kind of messy. Okay, and then so we have our grid there. So we have our position, we have our velocity. We're gonna say grid dot get grid dot get pause 1. We gotta flip them here. Dot get pause 0 dot add new robot, and we actually don't need to have this in there. We just need to have velocity. Actually, I don't even need to have a grid. I just need a list of robots. Well, if you just have a list of robots, that actually might be better. Just have a list of robots. Yeah, what am I doing? And the robots can keep track of their position themselves. And I'll just use modulo with these constants I have there. These are constants. Yeah, I don't even need a grid. If I'm going to use these robots, they can just keep track of their position themselves. So I don't need to do all that funky stuff. Arrays.stream. And now we can just say robots first of all. Well, yeah, now I can just map it. Robots equals, let's just put that down there. Robots equals arrays.stream. Oh man. Arrays.stream.map each line. Guess I could say yeah. And then just like return new robot. This would be pause. They're flipped, so pause 1, pause 0. Is the velocity flipped too? Means that second robot moves one tile to the right. Yeah, so those are flipped too. So velocity 1, velocity 0. Sweet. And then collect these to a list. Sweet. So we got our robots. we got our robots. Now we just need to move the robots. So 4 int second equals 0. Second is less than 100 plus plus second. Move bots. And to move the bots, we're just going to go for robot in robots. We're going to update its position with its velocity. And I can actually do that here. Update. I'll just say move. And we're gonna say I plus equals di, or actually I'll say I equals I plus di mod m, and j equals j plus dj mod n. That's the wraparound. And then I can just say, I don't even need a, I can just say for each. Sweet. And then I need to now let's make sure my robots look good. So yeah, let's print them out. Alright, that's going to be our, that's how we pin out the robots. Alright, let's print them suckers out and see what it looks like. 14 now. 14 sample. Oh, we didn't need to add the new line. And let's make sure that this checks out with our example. Sample. So at the end, what should it look like? We should have one. What? That's definitely not right. What's going on there? Huh. That's weird. How are we getting negatives? It kind of looks like to me. No? What is going on here? What in the world? Like, what's a negative? I forgot how negatives work with mods. Like, what would -1 mod 10 be? Should be 9, right? Yeah. What's going wrong here? How are we getting negative? That is weird. Let's see what my robots look like before. Yeah. Looks good. The robots look good. Somehow we're getting negatives in there. That's real weird. Huh. What? Are the velocities? I mean, what the heck? How are we getting negatives? How are we getting negatives, dude? That's weird. Yeah, remove the robots. Dude, what? What? What's wrong with that? Oh, so put it the wrong method. How the heck are these getting negative? How are they going negative? These robots should not be going negative. How the heck are they going negative? What? How are we going negative? 9. Huh. What in the world, dude? 10 and 3. Dude, what in the heck is going on? That is so weird. Let's see here. Select this. Plus DI. Oh. add M equals like this. Because we should not be going negative, dude. How are we going negative? I feel like I'm being dumb right now. Let's see here. So we're already going negative right here. -1 mod 7. So that should be 6. What? Hmm? Oh, interesting. It just doesn't work the same freaking way. I think I need to plus width in there. Yeah. Yeah, that's what you gotta do. Interesting. That didn't do it. How did that not work? Oh, because it's actually working now. So I get rid of all my. Just print them after. Let me rename this. And print those suckers out. And let's just make sure the robots are in the right spot. So we have, oh, that's only 1 second. So, let's see. We have one at 0. 1, 2, 3, 4, 5, 6. Yeah, I think it's probably right. And now I need to count how many robots are in each quadrant. So what's like 11 divided by 2? That's 5 in floor division. Five. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Yeah. And then you want to just basically ignore the robots that are dead center. Now let's see how this is going to work. So like quadrant. Let's not try to be fancy first. Let's just so 4 to I equals 0. I is less than m divided by 2. That's 7, so that'll be 3. Yeah. Int j equals 0. J is less than n divided by 2. And this would be the top left quadrant. And we'll just say sum plus equals robots.stream dot map to, or dot filter each robot to r.I equals I and r.j equals j dot count, or yeah. Yeah. What? Oh, okay. It's gonna be like effectively final. Let's do this. I'll just make a method for it. Now what are you mad at? Oh, that returns a long. Okay. So that'd be the first quadrant. I don't know if there probably is a pretty way. Give me a second here. Let's see. Yeah, because these are going to be like all pretty much the same. So then I'll do j equals n divided by 2 plus 1. J is going to be less than n plus j. And then 2 plus 1. And then just like that. Yeah, there's definitely a better way to do that. Maybe there's not. I don't really know. Let's just see if it works first. So that should Oh. Yeah, actually you want to safety score. Multiply them together, right? And this should return 12. No. Huh? Okay. Okay, so this is obviously doing something wrong here. What the heck, boy? What am I doing wrong? What am I doing wrong? What am I doing wrong? Nope, we got one. We got one. We got some more. So it should be 1 times 2 is 2. What the heck? Times 2 times 1. Wait, 1. Wait a darn minute. Oh, you're supposed to add these up and then multiply. And then just be like, Q1 plus equals that. And then you want to return like that. So you should be getting. $12. 0 still? Oh, what in the heck? How do I still have that there? How is that even valid syntax? Sweet. Well, that took a lot longer than it should have. That was pretty simple. We got our Wobots. Wobots. Sweet. Seems reasonable. No? That's too low? Oh, you know what? Am I overflowing? Very possible. It's a lot of robots. Could be overflowing. Oh, you know what I didn't do? I didn't change the dimensions of the grid. What is it supposed to be? Dumb mistake. It's supposed to be 103 by 101. Crap. Alright. Am I gonna have to wait? 7 seconds. 6, 7. Bam. During the bathroom break, someone notices that these robots seem awfully similar to the ones built and used at the North Pole. If they're the same type of robots, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that lasts for the robots to display the Easter egg? What constitutes a Christmas tree, man? No. Oh my gosh. Most of the robots should arrange themselves into a picture of a Christmas tree. Dude, how am I supposed to figure this out? What constitutes a Christmas tree? It's like a triangle. It says most of the robots, so I'm guessing more than half. Dude, what the heck? I think if I just print them out, I mean, that's a lot. That's gonna be a lot of iterations. Oh, only 100. I can scan through 100 things myself. All right. Print bots. Now, how am I gonna do this? I should set up a. Now it's beneficial to have a grid, actually. Robot stop for each robot. Grid. Yeah. And then return that grid, and then I can just let's do this. Okay. And then after each second up here, each second, move the robots. And then I'll say second. This is cool. This is a fun one. Print bots. And then let's do a new line. So it's gonna be 100 of them, so let's route this to a file and see if we can find the Cremish tree. Oh gosh. I thought this would be easier. Actually, I might be able to see it. Let's do a character array instead. Let's do a character array instead. That'll be better. That'll be better to see where the heck this thing is. So we're going to do a char. Equals just say equals a 0, something big. I'll do this. And for each row, arrays.fill that row with periods. Like that. Sure. Okay, try that. That should read a little better. Should be able to just see it on the side here. That's better, yeah. I could see that. I'm just manually looking for a Christmas tree. There's 100 of them, so let's just fucking... And it did say most of them, right? Oh, and this... Oh. Is that Christmas tree? Not really. I have a feeling it'll be like really noticeable. Maybe a 0 would be better. Let's try it with 0. Probably will be a little better. Yeah, that's a little better. And is this just 100, or is it literally just go? Dude, how are you actually supposed to do this? Like, without just... Is it still the 100? This one's kind of fun, though. I'm just wondering, like, how noticeable will it be? Is it gonna be like a big one? Oh, this is a crazy problem, dude. There's gotta be a better way to do this. I don't have any good ideas. Like, it's probably some big number, too. And I don't think... Dude. Oh, man. Interesting stuff. How in the heck? I know people have solved it by now. Like, it's been an hour and a half. Somebody has done it in 2 minutes. There's no way, dude. How are you finding the Christmas tree? Let me read the problem again. Maybe I misunderstood. Like, is it... let me read that again. Oh my gosh. During the bathroom break, someone else was... Oh wow, dude. Oh my gosh. How in the actual heck, bro? I gotta check something real quick. Gotta check on something. Yeah, I have a feeling you have to go through like so many. Probably like a ton, dude. A ton of seconds to find the Krimish tree. We'll figure it out. I'm just gonna check something real fast. Dang, did I get locked out? Okay. Oh, now we're connected. Sure is taking a long time. Yeah, that's the right password. Come on now. Just a second, I need to check something. 1 second here. Oh. Never mind, I got in over here. Just a second here. This thing is being mad slow, man. Let me turn the Wi-Fi off. Dude. Alright. And module load. And let's run this sucker. Dude, why is this so slow? Yeah, I'm gonna check it on here. This is way too slow. Uno momento. Sweet. When the heck are grades due? CSU. Grades due. Oh, okay. Grades are not even due yet. Okay. Some random student was asking me a question. I am a teaching assistant. Okay, how the heck am I gonna find this Christmas tree, dude? Actually, how the heck? What if I did like... Dude, what in the world? How am I gonna do this? I'm just gonna like manually do it. Ah! Let's do 1,000. That seems like not enough too. I just have a feeling it's like a lot. Oh boy. And there's like multiple ways that a Christmas tree, like, it. Why doesn't it tell you how a Christmas tree is? Oh boy. There's really no telling, dude. It's crazy. I actually don't know how I'm supposed to do this. Well, okay. Okay. I kind of have an idea. I kind of have an idea that involves symmetry. So like a Christmas trees are generally symmetric, right? I could come up with some way to kind of scan each one of these grids, and you basically just want to, gosh, it's gonna be like super slow, but I basically do like a sliding window, like a two-dimensional sliding window, you know, all sizes kind of, and I can come up with some kind of like similarity between the left and the right side, and if they're, well, that'll get me things that'll get me like kind of symmetrical spot, and things can be symmetrical without being a Christmas tree. Like, yeah, that's not the best idea. Dude. How in the world? Let's just like go through these. Here we go. Where is the Christmas tree? Dude, I'm not autistic enough for this. Bro, I need some help. Somebody help me. Somebody help, please. Is anybody watching? No. Dude. Oh my gosh. Bro. How you find Christmas tree? Like, the question is it like gonna be, you know, like what's the slope of the sides? Like how big is it? So many questions. Hold on. Did they link something? Maybe there's a link. No, there's not a link. I actually don't know how to do this. I don't want to look it up because I feel like there's probably some super simple way to do it. People did it in like a few minutes. What the heck? I mean, I guess I can use a language model. I don't know if a language model is going to do very good at this. Just set up a little API or like a set up a little program to send some API calls. I don't know if ChatGPT would be able to do this. It might be able to. I could actually turn these into PGMs. That would help me. That would actually help me a lot. Let's do that. Let's turn these into PGMs. Yeah, or like a buffered image or something. Let's do that. I forgot how to make a buffered image. Okay, I kind of have an idea. I kind of have an idea. I could turn these into buffered images. What the heck was that? And, let's see what I can do first. Let's see, I have a grid. Let's see. Buffered image, make image, and it's gonna take, I'll just take that char grid. And let's import this. Okay, I know there's a, let's see, I think it's an aught, Java. aught.io dot buffered image or something. Yeah. Is that not right? Might just be. Where is this? Aught image. Buffered image, and I need to give the width, the height. And what is image type exactly? Type of the created image. Oh, okay. Let's do we'll do RGB. So M, N. And what are the types again? How do you type that? Type. And how do you reference those? What do those belong to? Okay, buffered image dot type. Type. Let's do RGB. And image dot set RGB. Yeah. Image dot set RGB IJ. What's green? And let's see. Let's do image dot can you like image dot right or something? How do you write an image? Release to. Okay. Like this. Try that. Let's see what that looks like. See if I can work with that. And if that works, I can just like, I'm gonna just put them on like a grid, and then I can just like put them together all on one image. Oh yeah, I'm missing a little bit of conditional logic down here. If grid ij equals a 0, then set it to green, else image dot set RGB to black RGB int is 0, right? That's probably already 0 by default. What? How did we get out of bounds? Oh, they got flipped. All right, let's not print. Okay, I could probably work with that. So let's, whoa. Why are they kind of different? Interesting. That's really cool. But I feel like that's not doing something right. Like if I set RGB, it's already been set. And I feel like it's already going to be set to black. Did it again. Interesting. Why does it look like that? Huh. Why does it look like that? Is there like randomness in there? What's going on? What in the world? Can I save it as a PGM instead? Is that gonna change anything? Not PGM, PNG. Yeah, that's what I want to see right there. Cool. So let's put a bunch of those together. Let's put a bunch of these together on one image. So I'm gonna have a buffered image. Output equals new buffered image, and it's going to be 100 by 100. And then what is this? Image type buffered image dot type RGB. Oh, and it's actually going to be 100 times M. Wait. Width and height, so it's N times N, and then what the heck? Okay. Equals make image, make grid from bots, and then I should say output dot set. Assign a part buffer to another part, like that. Oh, set subimage. Oh wait. Huh? Like this? Try that. Wait, what is G? Huh? Image 2 dot create graphics. This would be, wait, which one are you drawing to what? Okay. Output. What? Java Auth Graphics. Java Auth Graphics 2D. Oh crap. Okay, yeah, it'll be X. I'm assuming it's N times second, M times second, N, M, like that, probably. And just like dispose it after the loop. Maybe. Might be really slow. It's making lots of images. It's gonna be a big image. Oh, what the hell? Not quite, huh? Not quite what we're trying to do. Yeah, I'm just making like a collage here. Well, let's see, second. I should do... Wait, what am I doing wrong here? Yeah, what am I doing wrong here? Um, oh boy, oh boy. And where would it be? This is the X. So it should be second. Second times n. That part's for sure. Wait, what? Why don't I just do this so I can not melt my brain. And this is going to be n times I, or n times j actually. I think like that. I think that's what I want to do. This one's crazy, dude. Okay. Wait, what the heck? Whoa. What the heck is going on there? Dude, it's huge. Oh my gosh. It's ginormous. There's definitely a cycle going on, right? Certainly some kind of cycle happening. I found it. Awesome, dude. Dude. Oh, dude. Dude, bro, that's cool. Awesome, dude. I just need to figure out what iteration that is. So cool. So in each of these images, let's put what I think with graphics you can draw text too. And then I can say G2 dot draw text, I believe you can. Text.
Oh, draw string. Wait, how do I know? How do I know what image or what iteration we're on? Would it just be I plus j? Right? No. Doesn't matter the language, but I always forget. Like this. Yeah. Row times width plus column. Now this is going to be absolutely slow as balls, but it's going to get me what I need, I think. I might need to set g2.set color to white. Isn't white? So what is that in integer value there? Oh. Color out white. Okay. Run it. What the heck? Okay, there it is. The font is a little big, huh? Let's just write the number. All I need is the number. Oh, and then... yeah, just do 00. 0. I like my solution. I think it's cool. Alright, there's the tree. That's a tree down there now? Or is there two trees? I think that's the one tree. Yeah. So cool. Dang, this is a cool problem. That was fun. But where is my text? Where is my text? I don't know, dude. Just do it like 100, 100. Ah, okay. Yeah, do this. I don't know. Let's just see if that worked. Let's see here. What? Are you sure? So what does it take? I actually don't really care about the font. Try that, and your string is going to be times... Oh, wait. Yeah. Wait. No, No, that's right. Okay. Eight 8168. Yes! Yes! I thought that was a cool solution. This just is how I did it. Really brute force. Yeah. How else were you supposed to do that? Was there another way to do that? Oh man, that's funny. It's actually really easy to see it too. Cool. And honestly, this stuff can be put in... that's fine. That's a cool solution, I thought. Yeah, there's just no way I would have found that. Wait, what? Yeah, dude, it was like 8,000 or some crap. Wow. Cool. I'll take it. Really not a way to write a test for that one. I'm really interested to see how other people did this. Okay, thanks for watching.